We shall talk about the Diac today. The full form of Diac is called as diode for. What is the full form of Diac? It is diode for alternating current or AC current. This is Diac. This is a PN structured. It is a 4-layer 2-terminal semiconductor device. So this can be switched off from the off state to the on state from either polarity of the applied voltage. So I can indicate the device. As I said, it is a 4-layer device. Suppose this is the third junction and the fourth layer. The first layer having N1, the second layer having P1, the third layer having N2, and the fourth layer having P2. This is N3. So let me consider this having the terminal T1 as MT, this as MT1 and 2. These are the two terminals. I can indicate the device as two diodes connected in anti-parallel. So this is how we can indicate denote the diode, and or in other words I can show it in this way also. So this is MT2 and this is MT1. So the diode for alternating current, it will conduct electrical currents only after its breakover voltage. So 3, 4 or 5 layered structures could be used, and behavior is very similar to that of a voltage breakdown of the triac without a gate terminal. It's very similar to that. So the Diac, the characteristics of the Diac can be studied. If I am going to draw the waveform, okay, from first I am draw the waveform with forward current and the forward voltage. How does the change in the voltage be indicated? See the voltage, it will increase from the 0 state. A small leakage current will flow up till the breakover voltage VB0. After that it will increase. Very similar for the negative breakover voltage, up to the reverse voltage it turns and then increases like this. One second, it will turn and increase. So this point where it breaks over is called as V reverse, or the leakage current is flowing over here, VB0. So see, this is the Diac. Whichever polarity, it can be switched from off state to the on state, or either from on state to the off state, depending upon the applied polarity. So when you are switching from off state to on state, when you want to switch it from off state to on state, what happens? avalanche breakdown will take either in either direction. So when you want to switch the diac from off state to the on state from either polarity of the applied voltage, VI characteristics is shown like this. So when the terminal MT2 is positive, if MT2 is positive with respect to MT1, that itself this MT2 is positive, and with respect to MT1 we know those two polarities N2 and P2 will become reverse biased. So the current will be flowing from terminals MT2 to MT1 through the path of see P1, N2, P2 and N3 in this direction. So if the polarity of the terminal MT1 is positive, to break the junction of N2 and P1, the current flows through the path of P2, N2, P1 and N1. If the applied voltage is either polarity is less than the avalanche breakdown voltage VB0, if it is less than this voltage VB0, the diac will be in the off state. So this is in the off state. If the voltage exceeds VB0, then it will go into the turn on state. So a very small leakage current will be flowing over here until then. So when the magnitude of the applied voltage exceeds the breakover voltage VB0, then the breakover takes place and the conduction will increase. So you can see that the current increases sharply. There is a sudden on state voltage drop. This is delta V. There is a delta V change. We can see it is changing here. This is delta V. Sudden change in the voltage drop. Now, if the diac is connected to an AC supply, what happens? This is the waveform. Suppose this is a supply I am going to give. One second. Suppose this is the omega T. This is the input voltage Vi. The load current flows only when the supply voltage exceeds the breakover voltage. What does that mean? Suppose this is the supply voltage. This is a supply voltage, input voltage. Then the diac current, this is a AC supply. The diac current will flow only after the breakover voltage. See, up till here nothing happens. Only after that is the diac will be in the off state only when the current voltage exceeds VB0, and very similar to the negative, if it exceeds minus VB0, then only it will start conducting. So it is like this. It will start conducting here. The diac will start conducting again like this. So this only when the value goes beyond VB0, then the diac flows. Then the diac conducts. Only when it exceeds the breakover voltage. Normally this diac are used in conjunctions with the other thyristors. Why? Because for generating the gate pulse, gate triggering signals. Okay. Thank you.